All right, so here we go, section 7.2. So we're doing radicals again, roots. Okay, square roots, cube root, fourth root, but they're gonna look a little different this time.
Would Rihanna just quick and Timmy McCartney come to the office, please?
So it says rational exponents. So I just said we were going to do like square roots, cube roots, fourth roots. And you're like, well, wait a minute. Those are roots. This says we're going to do exponents, but we're going to write them as exponents, okay? And you might have done this. My guess is you probably did a little bit of this in Algebra 1. All right, so let's go right to an example. And by the way, rational, what does that mean? You know what an exponent is, right? It's a what? A fraction. Yeah, basically a fraction. Okay, it could be other. Okay, it's basically a fraction. Okay, ratio, right? You're comparing two things to each other. So what are our exponents going to be then, according to this lesson? Our exponents are going to be fractions. That's right. Okay, so let's do the first one. So this is 16 to the 1/4 power. I should have done this. See, I didn't take notes on this. Now I got to read the book instead of just looking at examples. Let's just teach it this way. I'll tell you what. Let's do one that's just a little bit easier. What if I said this? What if I said 9 to the 1/2 power? What does that mean? Or you could just say, what is x to the 1/2 power? So when it's to the 1/2 power, it's the inverse of the second power, right? Okay, so when I think of taking something and squaring it, what's the inverse? What's the opposite of squaring something? Taking the square root of something. So this would mean the square root of x. Everybody see that? So that's what that means. You did that in Algebra 1, didn't you? Sure you did. You sure? Okay. So look at this. So what does this mean? To the 1/2 power means the square root of what? 9. So what is 9 to the 1/2 power? It's 3. So it's not 1/2 of 9, because half of 9 is 4.5. This is not 4.5. You're not taking half of it. You're taking it to the 1/2 power, which means you're taking it to a rational exponent, okay? Which means the 1/2 power means you're taking the square root of it. So what do you think it means when it says 16 to the 1/4 power? What do you think that means? It's the fourth root of 16. Very good. Okay, and we just finished talking about those things right there. So what number times itself 4 times is going to give you 16? 2. I could probably put it right there. You with me on that? On what that means? Okay, so 1 over. We're going to eventually, pretty soon here, put some numbers on top of there, right? Instead of always to the 1 over something power, we're going to mix it up a little bit. But not right now. Let's just do this. So the next one is, this is B. Scooch it up a little bit. So B is negative 125 to the 1/3 power. Okay? Now, does this mean I'm taking the negative to the 1/3 power? No, I'm only taking the what? The 125 to the 1/3 power. So you put the negative right here. And then what do we do here? What does the 1/3 power mean? It means we take the cube root of 125. Now, it really wouldn't matter, since this is a cube root, if the negative's on the outside or inside. But technically, that is on the outside of this, okay? Because what if it was to the 1/4 power? Then it'd have to be inside of there. I'm sorry. If it was, I didn't say that right. If it was inside of there, then you couldn't do it, right? Because you can't take the fourth root of a negative number, okay? Or any even power, or even root of a negative number. All right, anyway, enough of that. What's this? 125, cube root of 125. It's 5. 5 times 5 is 25. 25 times 5 is 125. So this is not just 5, but negative 5 because of the negative on the outside, okay? Does that make sense? Yeah, it's pretty easy. Let's do another one. Now, this is kind of what I was talking about a little earlier. Negative 9 to the 1/2. Now, look. What do we do here? Now, that negative is going to be inside the root, isn't it? because this whole thing is being taken to the 1/2 power, right? Now, earlier I said you can't have a negative if you have a positive root, but you can, but it's not going to be a real answer though, is it? It's going to be what? It's going to have an I. It's going to have an imaginary number. So what is this? This is the square root of what? -9. And we know how to work with that. It's just not a real number, but that's okay. It's still a number. What is it? 3i. You good with that? Yeah, pretty easy. Example 1. Now, let's do another one. Remember I said we're going to have some numbers on top as well? All right, so let me show you a little thing, and then we're going to do an example with that. So here's a little, they call it a definition. This is a definition of a rational exponent, is what they say. So it's x to the m over n is equal to a couple things. Now watch. This could equal x to the 1 over n to the m power. Would you agree with that? Why not? You know the rules. Watch. Watch. If I had x to the 3rd to the 5th power, okay, what do you do with the exponents here? You multiply them. So this would be x to the what? 15th. Okay? What do you have here? What, you got a power to another power. What do you do with these exponents? Multiply them. What's m times 1 over n? It's m over n. So you do agree then, don't you? Okay? Here's another way to write it. You could write it like this. Man, it's so small. Let me see. Oh, I did that one first. No wonder. Okay. You could write it like this. You could write it as x to the m to the, what do you think? 1 over n. Good. Because right here, wouldn't you agree that x cubed to the 5th would be the same thing as x to the 5th cubed? It's the same exact value, isn't it? Okay? So we could interchange them like this. All right? Does it make sense? What I usually do is this. On these problems, I like this way first. These are going to be numbers, okay? Like regular numbers. It could be a fraction, all right? And what I usually do is take the base, the x, to the 1 over n power first, and then I take that, and then I do whatever the top power says, all right? That wasn't the best way to explain it, but let's do a problem, and I'll show you. All right, 4 to the 3/2 power. So here's an example. This is example 2. Example 2. I'll keep that right there. And this says 4 to the 3/2 power. It says to evaluate, so you'll see that word on a lot of these problems. Just means figure out what this is, okay? And it does come out. It's simple. I mean, some books probably would say simplify, and that's perfectly fine. So here's what I do. If I see this is 3 over 2 instead of 1 over 2 now. It's not just a square root, is it? All right, because I got that 3 there. So here's what I do. I always like to take the base to the 1 over whatever the denominator is. Okay, so what would I write it as first? 1 over what? 2. All right, I'm going by this thing right here. You see that? But that whole thing is to the what? Is to the 3rd power. Would you agree that that's the same as this? Yeah, because the rule says you multiply exponents, right? When you have an exponent taken to another power, you multiply them together, 3 over 2. Sure, it's the same thing. Why did I write it like that? Because what is 4 to the 1/2? It's the square root of what? 4, all right? So I figure out what that is, and then I cube it. Make sense? Square root of 4 is 2. 2 cubed is 8, and that's what that is right there. So 4 to the 3/2 power is the same thing as just plain old 8. We okay with that? All right. I'm not going to write all this down. I did this. Let's see. Let me grab. I did this earlier, so I did a little bit to prepare for this. But I didn't have time to write all my notes out, but I did have time to do this. Woo, bigger than I thought. Let's do this. This is in the book. What's that? Feel what? Accomplished? Not really. I guess it does. Who knows? All right, there it is. Let's make it go all the way to here. Might make it easier to see. All right, there we go. Can everybody see that? I just figured it'd be a lot easier just putting it up here than it would be to write all this stuff down. So a lot of this stuff is just old stuff, okay? It's just review with exponents. But apparently, if you didn't do that negative exponent thing, you may not have done everything. But I bet you, tell you the truth, I think you've done every one of these, maybe except for the negative exponent stuff. So look at the we don't need to see the whole chart, so let's do it like this. All right? So x to the a times x to the b. So what do we do with those exponents? We add them up this time, okay? So for instance, like this, x to the 1/2 times x to the 1/2. You add the exponents, half plus a half is 1, so it's x. All right, easy. Quotient, what do? Subtract them. Take the top one minus the bottom one, all right? And that just gives you an example right there. This is straight from the book, okay? I literally did a screenshot of that thing right there, so it's right from the book. Here's what we just finished talking about. X to the a to the b. What do we do with the exponents? When you have an exponent taken to another power, you multiply them together. So look at this. X to the 3/4 to the 8th. What do we do with 3/4 and 8? You multiply them together. 24 over 4 is 6. X to the 6. Everybody good? It's just a quick review. What if we had all the stuff in the parentheses to the a power? Well, that means you take every individual thing inside the parentheses and take it to the a, right? So it's x to the a, y to the a. Same thing if it's being divided. X to the a over y to the a, right? That's all familiar, agreed? Zero exponent, we all know that. Anything to a 0 power is what? It's 1, okay? So anything, it doesn't matter how crazy it is, if it's to the 0 power, it's always just a 1. The number 1, not 1x, not 1 times a fourth, just the number 1. And here's the thing that we just finished doing. No, we didn't do this. I just did this. Or did we do this? No, I talked about this in my geometry class of all places. Last period, I did this. That's what I'm thinking. So what if I had x to the negative n? What does that mean? That means it's 1 over x to the positive n. We take that, we flip it to the bottom, right? Change the sign of the exponent. So if I take that whole thing, flip it to the bottom, change the sign of the exponent, I get x to the n. What's left on top? A 1's left on top, right? Because it's 1 times this. Does that make sense? So let me just show you this. A lot of people don't see that. So it's 1 times this. So what do I do with that? I flip it to the bottom. And then if I flip it, I got to change something, right? So I change the exponent. So there we go. So that went to the bottom. There's my 1 over x to the n. And you can flip it to the top. Look, if it's negative exponent on the bottom, what can you do? Flip it to the top, make it x to the positive n times 1 is just x to the n. All right, and they give you some examples just to show you right there. Oops, oh my word. What did I just do there? I hit Control-0. That's what I did, because it shows you the whole page. All right, enough of that. Let's do some more examples. That's what we came here for today, right? Do examples. All right, so example 3. All right, this time they give it to you in like square or root form, I guess, if you want to call it that. What do they call it? Radical form. They call this a radical expression, okay? So this is in radical form. And you want to convert it to exponential form. So you don't want the root. You want a bunch of bases with exponents, correct? That would be exponential form. All right. All right. So what do we do here? Let me just check this for a second. Uh, the 75, that's kind of weird. Let's kind of simplify that a little bit. Now, there's really not anything, because what times what's 75? 25 times 3, which means 5 times 5 times 3. That's it, right? It's the only thing that multiplies to 75. So I can't break it down where I have something you can take the fourth root of. Remember we did that yesterday? You took that big old number and you tried to break it down to see if there was anything to the fourth power. That doesn't work here, but you could, watch this, fourth root of, let's say, 3 times 5 squared. We'll come back to that, okay? Just leave it like that. Let's just come back to it. What's this going to be? This is going to be the fourth root of what? A cubed. And this is going to be the fourth root of b. Now, you may be able to skip this step, and that's perfectly fine. But this is the first time we've done this, so I'm going to show you that little step. So I'll tell you what, let's do this last. This part right here is the hardest part. This is super easy right here. So how do I write that in exponential form? So this is a cubed. How do I write the fourth root as an exponent? Take it to the what? 1/4 power. See that? And that's the same thing? Yep. The 1/4 power means the fourth root. So that's what I did. We got one more step after that, but that's an intermediate step. What about this? This is b to the what? 1/4. That's all I can do with that. What about this? I got a 3 to the first, right? So what's that going to be? 3 to the 1/4. And this is going to be 5 squared to the what? 1/4. That's all we did. We took everything in here, took it to the 1/4 power. The only thing I really did was just break down that 75 into this. Okay? Everybody with me? Yeah, I thought they might do something a little. Okay, that's fine. So what do I get here? I can't really break that down any further, so that's just 3 to the 1/4. What about this? I can do something with that. It's an exponent to another power. So what do I do? We can do a little bit of this in our head. What do I do with these two numbers? Multiply them. So that's what? 2 over 4. What's 2 over 4? It's a half. So this is 5 to the what? 1/2. See that? What's this going to be? A to the 3/4. And then I can't do anything with that. That's b to the 1/4. And really, they let you keep your answer just like that. You might have been able to do this, like 3b. This is what I was looking at to see if they did that. You could have done that. Would you agree? Because both of these are to the 1/4 power. Yeah, you could have done that if you wanted to. But they're okay with that because that's how they left the answer, just like that. So I just basically just took everything to the 1/4 power. And then I simplified as much as I could. Okay? Is that good? They have a part B to that. When are we out of here? 14? Yeah, I think I have time to do that. Let's do that. So this is part A. Oops. Part A, and this is part B. This one, you're going the other way. This one, they give it to you like this, and you want to write it like that. Okay? So it's 2 to the, oh my word, the writing is so small. 2 to the 3/5. 2 to the 3/5 times x to the 4/5 and y to the 1/2 power. Okay? Now, we want to write everything so it's under one big old root. Problem is, look, I got 3/5, 4/5, 1/2. It'd be really nice if I could put that into one root. What do you think that one root? Probably 10, right? I can't make a 2 into a 5, can I? All right? But I can make everything into a 10. So that'd be the smallest root. So guess what kind of root I'm going to have? A 10th root. Have you ever dealt with a 10th root? Me neither, probably. All right? So it's a 10th root of, let's see if we can do this in our head. You think you can? This is going to be 2, let's see. If I make this into 10, let's do this off to the side, the 3/5. Okay, if I make that into a 10, what's that going to be? It's a 6. So this is going to be 2 to the what? 2 to the 6th power. Do we know what 2 to the 6th power is? Let's go back a couple. Let's go 2 to the 4th. You know what 2 to the 4th is? What's that? 16. What's 2 to the 5th? 32. What's 2 to the 6th? 64. So 2 to the 6th power is what? 64. Make sense? Okay. What about this right here? Again, I want to make that to the 10th. So what's that 4 going to be? It's going to be an 8th. So it's going to be x to the 8th. I want to make that to the 10th power. So I had to multiply it by 5. Multiply that by 5. This is going to be y to the what? 5th. There you go. Yep. Yep. Does it make sense? Because you want to put it all under one root. So you got to find a common denominator, common root, all right? And then that's what you do. Yeah, it wasn't too bad. I'm glad we did that one. Let's do another one, example 4. Example 4. It says simplify each expression. All right, I see what they're doing. 36a to the 6, 36a to the 6, b to the 12th, b to the 12th, and that. Now watch this exponent. You don't usually see this, but this is to the 1.5 power. Well, what's 1.5 in your head? What is it? Yeah, it's a fraction. 3 over 2, right? Because that's what we're kind of dealing with now, aren't we? So wouldn't it be better to go 3 over 2? It's 1.5. Yeah. All right. So that'll help us out a little bit. So let's write these down. What do I got? I got 36 to the what? 3/2 power. I got a to the 6 to the what? 3/2 power. Then I got b to the 12th to the 3/2 power. All right. The variables are actually the easy part. The number is a little bit tougher, but we might be able to do a little bit of this in our head. How am I going to do this? I'm going to go 36 to the what? No, not yet. Because can you do 36 to the 3rd power in your head? I mean, you could go that route, okay? It would work, but I don't know what 36 to the 3rd is. And then you're going to get some big giant number, and then you're going to have to take that to the 1/2 power, which means you're going to have to take the square root of it. Oh, that sounds terrible. If you have a calculator, it's not that big of a deal. But what's a lot easier? Taking 36 to the what? 1/2 power to the 3rd. That's a lot easier. Wouldn't you agree? Okay, so let's do it that way. We'll finish that in a second. What about this? What do we do here? What do I do with those exponents? Multiply them together. So that 2 goes into the 6, what? 3 times. So this is a to the 9th. Everybody see that? What about this? You multiply those together. That means 2 goes into the 12 6 times. This is b to the 18th. Let's finish this up. 36 to the 1/2. We can do that in our head. What is the square, right? It's the square root, isn't it? What's the square root of 36? 6. So this is 6 to the 3rd. Well, 6 times 6 is 36 times another 6 is, what's that? 36, 18, 21, 216. Is that right? Did I do the math right? 216, and then a to the 9th, b to the 18th. Let me just double check. So what is it? Yes, it is. Okay. And there you go. Yeah, we'll just keep it like this. Okay? Make sense? Yeah. Yes, ma'am. I know. That's what I was thinking about there for a second. I was going to talk about this is actually an absolute value because when you take, because you would have had this. You would have had a to the 6 to the 3/2, correct? Which means it's a to the 6 to the 1/2, which means you're going to take the square root. Remember, we take the square root of a even exponent, that becomes a absolute value. Remember that? That's why they put the absolute value there. I would not mark it wrong. Okay, I would not mark it wrong if you don't put the absolute value there. All right. Why is what? I can't hear you. You got to speak up. Good question. Let me see it. Oh, because it eventually comes out to b to the 18th, and anytime you have an even exponent, it's always going to be positive anyway. So I don't have to say that this is going to be absolute value, because when I take it to the 18th power, that automatically makes it. Since this came out to the 9th power, this could possibly come out negative, right? If you put a negative in here to the 9th power, that'd be negative. But in this situation, right, it has to be absolute value. Good question. Okay? Um, uh, so many. What did I say? 14? Okay, I think we still got time. This is part B to that example. 216 x to the 9th. 216 x to the 9th over 125. And this is to the 1/3 power. Okay? All right. Well, let's put everything to the 1/3 power. They don't do that in the example, because I'm looking at how they do it. If it was me, I would probably do this. I would go 216 to the 1/3. Then I would go x to the 9th to the 1/3 over 125 to the 1/3. Okay? So let's think of 216. This is to the 1/3, so it's cubed, right? So I need to break it down where I have groups of 3. 216, I don't know. Didn't we just do 216 though? Yeah, so what is it? It's 6 to the 3rd, right? Yeah. So this is just a 6. Is that right? Yeah. Yeah, they do a whole bunch of other stuff with it. I think it's a lot easier just doing that. Yeah. The cube root, right, of 216, we just did that on the last problem, is 6, so that's just a 6. What's this going to be? The x. X to the 9th to the 1/3. What do? We multiply them together. What's the third of 9? It's just 3, so it's x to the 3rd. Over, and we should be able to do this in our head, right? What's the cube root of 125? It's just 5, boom. They do it way more complicated than I did. I think that's a lot better. Okay? Yeah, they split it all up and do a bunch of stuff. I just think that makes more sense, don't you? All right, let's do example 5. Are you liking these or not? 4th root of 1024. This is a 4th root. Again, I'm kind of not digging what they're doing here. Okay? What's that? 8? Is it? No, 4th root. Oh, is the answer 8? Is that what you're saying? I don't think it is. So what I would do is this. I'd off to the side, I'd take 1024, and I start breaking it down. Remember, I want to group them into groups of 4 if I can. All right? So 1024. What do you think? Well, 2 goes into it, right? Would you agree? So what would that be? 562? 62? Is that right? Who's got a calculator? Should be able to do that in my head. I think I did it. 1024 divided by 2. 512. What am I doing? 512, of course. 10 divided by 2 is 5, and 24 divided by 2 is 12. I don't know what I'm thinking. All right, so what do you got? 2 times 5, 12, right? Break 512 down. Take that. Oops. Take 512, divide that by 2. And that's 256. So I got a 2, I got a 2, and I got a 256. I mean, you could try bigger numbers. I'm gonna stick with 2 from 128, right? 2 times 128. 2, 128. I can still divide that by 2. That's 64. Now I'm finally at a number I don't have to put it into a... Well, of course, I could have done that without a calculator, too. Here's another 2. Right, I'll put it right there. What? My word. You guys are so picky. I thought I was picky. Like, put it right there? Okay. Times 2. Is that all right? Put dots in there. That didn't bother you, not having the dots? It bothered me. That one doesn't have a dot. There we go. All right. Well, we got that. We got a group of 4 right there, so that's nice. What about 64? Can we break that down? Yeah, it's 8 times 8, right? That's 2 times 2 times 2. There's your 1 8, and there's your other 8. Okay? So break these down. There's your 4 right there. So what do we got? We got 2 to the 4th. We got another 2 to the 4th. And we got a 2 squared, which is just a 4. Agreed? Yeah. Is that what we're trying to do? Yeah, because it's the 4th root, right? So the 4th root of 2 to the 4th is, so let's put it in here. So we got a 2 to the 4th, we got a 2 to the 4th, and we got a 4. So what's the 4th root of 2 to the 4th? 2. This is a 2. 2 times 2 is 4. 4th root of 4. Is that the answer? Probably not. What did I not do? They put 1024 as 2 to the 10th. 4 squared of 2. 4. There's 10 twos, right? There's 6 and there's 4. There's 10. What did I do here wrong, though? I messed up somewhere. 2 to the 4th is 2. Oh, I think I screwed up right here. So let's... I was trying to go too fast. So the 4th root... Watch. The 4th root of 2 to the 4th... That's a 2, isn't it? Okay. Right here? Well, because it's 2 squared to the 1/4. Okay. Yeah. Right? Because 2 times 2 is 2 squared. But that's a 4. See, so really, the only thing... So I did this part right. This part right here, the 4th root of 4, you can simplify that a little bit more. So that's what they did. All right, so I was on the right track. So...
Is that what you say on my test, Mr. Hamlet?
Hey, I'm not taking a test now, right? I didn't even take notes on this. I'm going right from the book. This is all by the seat of my pants. So you got to give me a little break here. So what is this? This is 4 is 2 squared, right? Everybody see that? And so this is 2 squared to the 1/4, which would be 2/4 is 1/2, which is a square root of 2. So that would be, so this is the same thing as the square root of 2. So this was correct, just wasn't completely simplified. All right, so that is your answer. So I was doing it right. Believe me, if I'm doing something wrong, I'll tell you. I'll admit my mistakes. I have no problem with that. We got one more to do. I'm not going to worry about that last one. Okay. Square root of 8. Okay, watch. This last one, bear with me. I told you there's a lot of examples. So we'll see how they do it. So they say, put this into exponential form, okay? And I would agree with them that that's the best thing to do right here, because you can't really do a whole lot with this, okay? But you can do stuff when you put it in exponential form. So what is this? This is 4 times 2, correct? I'm going to do a little different than they do. This is how I would look at it. I would go the square root of 4 times 2. So that's 2 square root of 2. But if we put it in exponential form, it's what? It's 2 to the first, 2 to the 1/2, which will give me 2 to the what? 3/2. So that's what the square root of 8 is, 2 to the 3/2. Yep. Everybody with me on that? All right, so let's do the bottom. So I got a 4. Do I want to just keep it like that? Let me take a peek. Yeah, we're going to make it 2 squared again. All right, so watch. 4 is 2 squared, but it's the cube root, right? So it's to the 1/3. So what is this? This is 2 to the 2/3. Okay? So here's my numerator. Here's my denominator. Let's write it as a nice fraction. 2 to the 3/2 over 2 to the 2/3. Okay? You got the same base, don't you? So I can keep the base the same. What is that rule? Remember that rule that I put up there with quotients? What do I do with the exponents when they're being divided? I subtract them. So this would be what? 3/2 minus 2/3. All right? And let's just do the work. Let's do it over here, make it a little bit bigger. 3/2 minus 2/3, common denominator, 6. 2 times 3, 3 times 3, right? 3 times 2, 2 times 2. 5/6, is that right?
Yeah.
So 2 to the 5/6. Is that how they write the answer? Yeah, and then they change it back into radical form. All right, so this is the same as 2 to the 1/6 to the 5th. Why did I do that? Because I want to be able to write it as a radical. So that means it's a 2 in here. It's to the 6th root, and this is to the 5th. Where do they put it inside of there? Or you could put it outside. It really doesn't matter. You could put it right there. So they leave it like that. And then here, one more thing that they do. They figure out what 2 to the 5th is. What is 2 to the 5th? 2 to the 4th is 16. To the 5th is 32. So there you go. So that is that right there. Did you write all that down? Didn't. I mean, the math is really not that hard, is it? You just, it's very, I don't know, what's the word? Tedious. That's the word I was looking for. It is. It's very tedious. Okay? It's not necessarily difficult, but it's definitely tedious. All right? Anybody still awake? I got 1, 2, 3, 4 heads down. Out of what? How many are in here? Like 15, something like that? Oh, my word. Okay. Yeah, I'm sure you are. All right. That's it. I think, well, you got homework to do. Last homework. 1 to 39 odds. We're just going to go over homework tomorrow. So 1 to 39 odds. I doubt it. All right, so 1 to 39 odd. That's section 7.2. Why don't you just hang on to section 7.1, and we'll just use tomorrow just as a question answer day. All right, and we'll go over 7.1 and 7.2. Is that all right? So if you did it, if you did 7.1, just hang on to it. If you didn't do it, now's your chance to get it done. All right, then it won't be late. So that's good. But then you got 7.2 to do as well. But again, that's only like 20 problems. 20, that's not that big of a deal. My other school, I gave 30 every single night. Because the book, every single problem set had 30, and they wanted you to do every single one. Every night for homework, I give them 30 problems. It was good. It was a good program. I like that program.